All right, welcome. If you're going to work with data, you've got to know what you're actually working with. Today, we are digging into the absolute fundamentals, the real blueprint for any kind of data mining. So yeah, let's just dive right in. And you know what? That's no exaggeration. Think about it. Just like a skeleton holds up a body, understanding your data types supports every single analysis, every model, and every insight you'll ever find. If you get this right, everything else just clicks into place. Okay, so first things first, what are we even looking at? In the world of data, that thing is your data object. It's the who or the what of your entire study. Let's say you're analyzing sales at a store. Well, each customer is a data object. It's really that simple. Now, once you have your object, let's stick with our customer. How do you actually describe them? That's where attributes come in. These are all the details, the little characteristics. What's their age? What's their income? These are the attributes, and they're what bring your data object to life. So believe it or not, pretty much every attribute you will ever run into falls into one of two major families. You can think of this as the first big fork in the road. Are we talking about a quality you can describe, which we call categorical? Or are we talking about a quantity you can measure, which we call numerical? So this slide here, this is basically our roadmap. You can see at the top we have our attributes, and they branch out into all these different types. We're going to walk through each one of these, starting with those categorical types, nominal and ordinal, and then we'll jump over to the numerical side. Let's start with categorical data. This whole family is about qualities, labels, and different classifications. We're not dealing with numbers you can add or subtract here. Nope. We're talking about groups and names. Okay, so the most basic type is nominal. The best way to think about these is as simple labels. You can't say blood type A is somehow greater than or less than blood type B, right? They're just different. There's absolutely no natural order to them. And next up, we've got ordinal data. Now with this one, the order definitely matters. We all know a PhD is a higher level of education than a bachelor's degree, but what's the exact distance between them? You can't really measure that. It's a rank, not a precise measurement. All right, let's switch gears and jump over to the other big family, numerical data. Now we're in the world of stuff we can actually count and measure. This is where the numbers really start to do the talking. Okay, pay attention here because this difference is subtle, but it is incredibly important. Ratio data has something we call a true zero. For example, 0 kilograms literally means no weight. It's an absence of the thing. This lets us say that someone who's 100 kilograms is twice as heavy as someone who is 50 kilograms. But now look at interval data, like temperature in Celsius. 0 degrees doesn't mean there's no temperature or a complete absence of heat, right? It's just the point where water freezes. Because of that, you can't say 20 degrees is twice as hot as 10 degrees. It doesn't work. That true zero is the whole game changer.
And within numerical data, there's one last split we need to talk about. Is it discrete or is it continuous? It's actually really simple. Can you count it or do you have to measure it? You can count the number of children in a family. 1, 2, 3. You can't have 2.5 children. That's discrete. But you have to measure height or time, which could be any value within a range. That's continuous.
I know, that was a whole bunch of definitions. So let's make sure this all sticks with a really simple analogy. Just imagine you're at the finish line of a big race. This really just nails the difference, doesn't it? The colors of the runners' jerseys, red, blue, green, that's your nominal data. They're just labels to tell the runners apart. Then you have the medals, gold, silver, bronze. That tells you the rank order of the finishers. That's ordinal. And finally, you've got the actual finish times, 9.81 seconds, 9.92 seconds. That's ratio data. It has a true zero, which is the starting gun, and it lets you calculate the exact difference between the runners. Of course, in the real world, data is way messier, right? We often have to deal with these really complex types, like raw text from social media posts, images, videos, even map data. The good news is, the fundamentals we just covered, they are the building blocks you need to handle all of this stuff. So at this point, you're probably thinking, okay, cool, definitions, but why do I actually need to know any of this? And honestly, that is the most important question of all. Here's why. Knowing your data type isn't just some random detail. It dictates your entire toolkit. It literally tells you which machine learning algorithms you're allowed to use, what kind of prep work you need to do, and at the end of the day, how to correctly interpret your results. You can't calculate an average blood type, for example. The whole analysis starts with knowing your data type. All right, let's see if all that has landed. Time for a little quick quiz to test your knowledge. You ready? Okay, first one, the number of patients in a hospital. Are we counting them or are we measuring them? What do you think?
The answer is discrete. You count patients in whole numbers, 100, 101, 102. You can't have half a patient, so it's got to be discrete.
Next question for you. Think about a movie rating, 1 to 5 stars. Is that ordinal, meaning it has a rank, or is it just a nominal label? Take a second on that one. That's right, it is ordinal. We can all agree that 5 stars is better than 4 stars, so there is a very clear, meaningful order to those ratings. And for our last one, let's get a little more conceptual. Why can't we do math like adding or subtracting on nominal attributes, like blood type or jersey color? Because they're just labels. That's it. They have no natural order or value. Trying to add blood type A to blood type B is just as meaningless as trying to add the color red to the color blue. So there you have it. Data objects, attributes, these really are the essential blueprints for all data mining. Getting this stuff down is your first and most critical step. So the only real question left is, now that you have the blueprints, what are you going to build?